Hello, welcome to Engineers Mindset. Okay, so let's say we have this function and we are asked to find partial z, partial x, and also find partial z, partial y. So differentiating the function z with respect to x partially and differentiating the function z with respect to y partially. So let's treat partial z, partial x for this given function first. Okay, so we have that z is equal to this is 2x squared y plus xy into y squared minus 2x. All right, so we have this. First thing, I will say let u be equal to 2x squared y plus xy, and let v be equal to the other term here, which is y squared and minus 2x. So this is what I've done. I've called the whole of this term to be u, and I've called the whole of this term to simply be v. That means this actually now implies that z itself is simply what? In place of 2x squared y plus xy, I simply call that u times, in place of this y squared minus 2x, I simply call that v. So which means now I'm going to employ, because this is actually u times v, this actually means I'm going to employ the product rule of partial derivative to differentiate this function. Now, what is the product rule? It's still the same thing as product rule in normal derivatives. Okay, the only problem now is that this is going to be dealing with partial derivatives. So you keep one function as constant, then you differentiate the other. That's why it's called partial. Okay, so let's say I want to differentiate z with respect to x. Partial z, partial x. Okay, so from product rule, I'm going to simply have this is equal to, the rule says keep u as constant, then differentiate v partially with respect to x, plus now keep v as constant, so you have v, now you differentiate u partially with respect to x. So this is what I will do. I already know the value of u. I said let u be the whole of this. I also know the value of v. I said let v be the whole of this. So the only thing I want to look for now, or I'm supposed to look for, is simply to find the v dx and the u dx. That's all I'm supposed to find. So from v equal to y squared minus 2x. I want to find the v dx, partially differentiate v with respect to x. When they say partial derivative, if I say I want to differentiate v with respect to x partially, it means that I am going to consider y as a constant. So the same way I will treat a constant in normal differentiation, that's how I will treat y. Y will be considered as a constant because I just want to differentiate v with respect to x and not with respect to y or any other variable. Okay, that means from here I will simply have partial v partial x is now equal to, so since this is a constant, all right, so it means the derivative of a constant is 0, so this actually gives me what? 0, because y does not contain the value of x. So the derivative of every constant is 0. So since there is no x here, it means the derivative of y squared automatically gives me 0. Okay, minus this now contains x. If I differentiate this with respect to x, of course, this x here has a single power. If it has a single power, it means the derivative is actually what? 2. The variable attached to what? The number attached simply to x. Okay, so this simply gives me what? 2. If I differentiate x, I will simply have 1. So 1 times 2 simply gives me what? 2. So I have this. So this simply means that the v dx partial v partial x is actually what? Minus 2. So take note, since there is no x attached to this guy, to the y squared, it means I'm going to treat y squared as a constant because I am differentiating v with respect to x. So therefore, I will treat y as a constant. And you know in derivative that if you differentiate a constant, you have 0. So since there's no x here, I differentiate y squared, it becomes 0. Minus, I have 2x here. If I differentiate x, since x is raised to the power of 1, if I differentiate x, I will simply have what? 1 as a value. Now, 1 multiplied by 2 simply gives me what? Minus 2. So it means the v dx is actually what? Minus 2. So I've obtained this part of the question, the v dx, or this part of the formula. Next is to obtain what? Du dx. So you also call from u. So from u equals, we have 2x squared plus xy, 2x squared y, okay, plus xy. All right, so I want to differentiate u partially with respect to x. So as always, you are only differentiating with respect to x. So you consider every other variable there as a constant. Now, this is like saying product true or implicit true, because I have x multiplying by y. I still have 2 multiplying x squared and y. So what I will do is this: 2 and y are constant, so keep it out. Then differentiate x, because I'm differentiating u with respect to x. If I differentiate x, here is I have x squared. If I differentiate x squared, simply use the power to multiply x. That will simply give me 2 times x, and then subtract 1 from the power. 2 minus 1 gives me 1, so I still have 2x. So if I differentiate x squared, I simply have what? 2x. Okay, close your brackets, plus, okay, same thing happens here. Y here is treated as constant, so you keep it aside, then differentiate x. If I differentiate x, I simply have 1. You simply have this. Therefore, du dx is now equal to, this 2 times 2 gives me 4. I'll simply have 4xy, okay, plus y. So this gives me du dx. All right. So if I have du dx, I have du dv, I can now plug into the formula for product true and obtain the partial derivative of z with respect to x. All right, so partial x is now equal to, first of all, we said keep u constant, and u is simply 2x squared y plus xy. So you simply have 2x squared y plus xy multiplies by, next is what? Dv dx, and dv dx simply gave us minus 2. So multiplies by minus 2, okay? Plus, we say now keep keep v constant, and v is actually y squared minus 2x. You simply have y squared minus 2x. Now you differentiate u with respect to x partially. Differentiate u with respect to x, and that gives us 4xy plus y. You simply have times 4xy plus y. So you have this, okay? All right, so you may wish to want to expand the brackets, and if you do that, you're going to have this to be equal to 2x squared y multiplied by minus 2 gives us minus 4x squared y. Okay, minus 2 multiplied by xy gives us minus 2xy. Okay, here you can expand the whole of this with this and this. So y squared multiplied by 4xy gives me plus 4xy cube. Okay, y squared multiplied by y here simply gives me plus y cube. Okay, minus 2x multiplied by 4xy gives me minus 8x squared y. Okay, minus 2 multiplied by y gives me plus 2xy. Okay, so notice here that I have minus 2xy, I have plus 2xy. So these two can actually strike out. So those two are gone. Okay, therefore, here also I have minus 4x squared y. I have here minus 8x squared y. That gives me, okay, partial z, partial x is equal to, so this gives me actually minus 12x squared y. Okay, I have here plus 4xy cube plus y cube. Okay, all right. Okay, so you may choose to leave your answer like this, or you may choose to factor out y. Since y is common, you can factor out y, or you can choose to leave your answer like this. So this becomes the partial derivative of z with respect to x. Now let's also try this, solving partial derivative of z with respect to y. Still the same thing, everything here remains the same. The only thing that changes now is that the law is now going to be what? Differentiating z with respect to y. So which means this is going to be partial z partial y, then keep u constant, differentiate v partially with respect to y, plus differentiate u partially with respect to y. That's the only thing that changed. Okay, so we're simply going to have partial z partial y is now equal to partial v partial y plus, okay, this becomes partial u partial y. So keep u constant, differentiate v with respect to y, plus keep v constant, differentiate u with respect to y. That's the law. So that means all we are doing now is, since we know u and we know v, we only have to differentiate v partially with respect to y, and we only have to differentiate u partially with respect to y. Okay, let's try it now and see. Okay, so from v equal to y squared minus 2x, I want to differentiate v partially with respect to y. That means I want to differentiate only v with respect to only y. So I'm not differentiating x, I'm only differentiating v with respect to only y. That's what it means. Okay, so which means if I do that, if I differentiate y here, I will simply have what? 2y. Of course, 2 multiplied by y, then subtract 1 from 2. That gives me 2y. But here, there is no y here. I only have 2x. So I will treat those two as what? Constants. And the derivative of a constant always is 0. So that means this is going to give me minus 0. So this simply implies that partial v partial y is actually what? 2y. So you have this. So this part of the formula is solved. Next is to find what? Differentiate u with respect to only y. So from u equal to 2x squared y plus xy, 2x squared y plus xy. Now you have x attached to y. So what we're interested in actually what? Differentiating u with respect to what? Y alone. We don't want to differentiate u with respect to x. It's just with respect to y. And we have y attached to all the x variables here. So what we'll do is simply treat x as constant. So we have 2x squared here treated as constant. So keep it out. I want to differentiate u only with respect to y. So I will only differentiate y here. And if I differentiate y here, I will simply have what? 1. Because this is same as saying y to the power of 1. And from the formula, use 1 to multiply y, then subtract 1 from 1. It becomes y raised to the power 0, which is 1. So differentiate y, I will simply have 1. Okay, plus also keep x here as constant. I only want to differentiate y. So if I differentiate y, I will also have what? 1. So this becomes partial u partial y is now equal to, so I will simply have 2x squared plus x. This becomes partial u, partial y. So this side of the equation is solved and this is solved. Next thing to do is simply what? Plug in those values into the formula and then you obtain your derivative. Alright, so the partial derivative of z with respect to y is now equal to, so from the law, keep u constant and u is simply 2x squared y plus xy. So you simply have 2x squared y plus xy, okay, then multiply by derivative of v with respect to y, and partial v partial y gave us simply what? 2y. So we simply have multiplies by 2y plus, now you keep v constant and v is simply y squared minus 2x. I have y squared minus 2x, okay, and then you differentiate what? U with respect to y. The u dy gave us simply 2x squared plus x. So we simply have 2x squared plus x. Okay, so you may wish to also expand the bracket and see if anything can go. Alright, so if I expand this, I will simply have 2x squared y multiplied by 2y simply gives me 2x squared y squared. Okay, minus xy multiplied by 2y simply gives me, okay, plus xy multiplied by 2y simply gives me plus 2xy squared. Okay, here too same thing, y squared multiplied by 2x squared simply gives me plus 2x squared y squared. Y squared multiplied by x simply gives me plus xy squared. Okay, minus 2x multiplied by 2x simply gives me minus 4x. Okay, minus 2x multiplied by 2x squared, that's 4x cubed. Okay, minus 2x multiplied by x simply gives me minus 2x all squared. Okay, so partial z partial y is now equal to, so I have 2x squared y squared, I have 2x squared y squared, they can add. So 2x squared y squared plus 2x squared y squared simply gives me 4x squared y squared. I also have 2x y squared plus xy squared here. So they can also add. That gives me plus 3xy squared. Okay. I have left minus 4x cubed, x cubed, okay, minus 2x squared. All right, guys, so you may wish to leave your answer like this, or you may wish to also factor x out because x is in all of them, but this becomes the answer to that derivative. All right, guys, I hope you enjoyed that wonderful problem on partial derivative. Please share your thoughts in the comment section. I will see you in the next video with more amazing question on partial derivative. Thanks, guys, and cheers.